Hello guys, welcome back to my channel. Based on African motives, still working on O-level maths. Is in this platform we just want to have a continuation, which is actually your request to finish up this question paper that we started November 2012 paper 2, which is a replacement paper. So I'm not going to waste much time here. We just want to quickly see what we're supposed to have in this question paper. Actually, I worked out this up to question 5. I think up to question 4. We're left with question 5 up to the end. So we shall see from this question 5. So in question 5, answer the whole of this question on a sheet of plain paper. So that means we are supposed to be having a plain paper here for these constructions to be done. Anyways, it's a triangle, a simpler triangle, PQR with the QR 8 centimeters, PQR 45, QRP 60 degrees or something like that. So all you need, guys, I told you, whenever dealing with construction, make a sketch, okay, of the information that you're going to have. So this is a triangle that we are just referring to, PQR, and we are given angle Q. This is angle Q here. This is angle R. So which means these angles should be on the base, 45 and 160. So I'm just going to put my Q here and my R here. So it is going to be PQR like this, PQR. And so I can just put these measurements from Q to R, it's 8 centimeters. And PQR, this angle here is 45 degrees. And QRP, Q to R to P, it's 60 degrees, just like that. So this is a sketch. So as you can see, guys, it was actually easier and simple to have this. So let us just put in our construction now from this sketch that we're having here. We are going to have our constructions now. So I'm just going to have my instruments here so that we'll be able to apply them, the ruler and this. Okay, this is what you actually need. All right, so according to this part, guys, as you can see, we are going to have actually a line that you're going to use for these constructions. So actually, guys, I think this part, we are now used to this. Always construction has to start from a line, a certain point that you're going to use as your reference point. So when we have our 45 degrees, okay, anyways, let us just start by marking our point, which is our reference point, the one that I'm just going to use. In this case, this is our reference point. All right, so at least it was just going need to be, let me remove it so that it can be actually something nicer. All right, just something like this, just your point. So remember, 45 degrees, guys, is being constructed from what? From 90 degrees. You're going to construct 90 degrees, then you bisect that one, you've got 45. Okay, so that's our point Q here. So remember, guys, to construct 90 degrees, what I said, we just need 2 points that you're going to mark from what? From the reference point, which is this one. You mark a point here, mark another point on the other part from the reference point. Then you're going to step on those reference, on those points or the arcs that you've marked now. Just open more than half of the line. Okay, so just going to open more than half of the line and you construct an arc on top and another one below. But since we've got a reference point, there's no need for us to construct this arc from bottom and also below. Just construct on top there like this. Then on joining, it means you're going to join from the point of intersection to Q. So there's no need for us to have 2 points, one down and the other one on top. No, guys, that one was just a basic way of showing you what you're supposed to do, but it's actually not necessary because 2 points are enough like this. As you can see, your 90 degrees can be formulated. So we do not need to have many points. So if I'm to join this part, take note, I do not need this. So I'm going to put it as a broken line because I need 45, not 90. Okay, so just put this as a broken line through Q to that point, at least a little bit from that point like this. Okay, now for us to have, because we're supposed to have 45 degrees from this 90 degrees, this is 90, this is 90, and this is inside the triangle. So we're going to bisect the right hand side, on the right hand side, not the left, but the right one. Okay, so how do we bisect an angle? Okay, this all we have it in our notes there, guys. We're just going to construct an arc on the line of your choice, guys, of your choice. This arc is of your choice. Okay, So it's not like something which is you're going to be forced to say at this point. No, it's just an arc of your choice. So like this part, I'm just going to construct my arc of my choice here. I hope it's going to be, let me see this side. It is going to pass through. Yeah. So I'm going to start with this one. I'm going to mark an arc here and mark another arc on this line. From those arcs, without changing this distance that you see, don't change it. Just go to those two arcs that you have marked. You construct now an arc inside where you expect your 45 to be. It's supposed to be within this region. So where you expect your 45 degrees to be, that's where you just construct your arc here. You do the same from that point of intersection on the other end. You're supposed to construct your arc on the other end. As you can see, these two arcs, they do meet at a certain point. Where they meet, you have to join back to the center, which is the Q there. So just like we are referring to Q as our center for the meantime. We are not saying, sorry guys, sorry for this. I'm not saying it's actually a center, but I'm just saying that's your reference point, that Q. So it's actually a reference point, all right? So gonna have something like this. Okay, somewhere here. Is that so? Or is supposed to be to something like this? So guys, this for me is gonna take some time for me to actually locate this angle, but somewhere here, yeah. Okay, so from there, we are now joining. And this one has to be a continuous line. Remember construction, guys, you join throughout like that. All right, so this is our 45 degrees that we are having at Q. So you can just indicate to say this is 45 degrees, okay? From Q to R, we have got 8 centimeters. But I think, guys, I've explained that if I am to use the ruler to measure the exact 8 centimeters, not going to work here. So I'm going to measure my 8 centimeters from this thing here. This is my 8 centimeters here somewhere. Okay, 8.1, 8. Yeah, okay. So this is my 8 centimeters. Let's say this is your 8 centimeters on your ruler there. But as for me, that is the one. So on your ruler, it's going to be bigger than what you are seeing here. But the diagram is going to look the same like this. So this is our 8 centimeters from what? From Q to R here. So this is our R at this point, and we've got 8 centimeters like this. Okay. At R, what is going to happen is that you're going to construct 60 degrees here, and this 60 is on the left side, it's on the left-hand side. Remember, I told you can construct 60 on the left side or on the right side. Okay, so we want 60 on the left side. So the arc that we are going to use should be on the left side like this. Okay, so you just have something of this nature here. Let me say this is what I'm going to have. So remember, you construct a semicircular arc. Like I think not supposed to be a semicircle, but that one is fine. Where this arc meets with the line, we have to join back to that major arc that you were having before, which is this major arc here. So you join to that arc like that. By doing this, guys, it's actually enough for us to join here these points and have what? Our 60 degrees. Okay, so I'm just going to have it this way, somewhere here. Okay, to this point R like this, I'm going to join. So by joining here, there is a miracle which is happening here. And what is that miracle? These angles, the lines that we constructed from Q and this line that we constructed from R here, they do meet at a certain point here. Where they meet, that is where our P is located, because we do not have a reference point to say this is where our P is. But according to the point of intersection, because you have got two angles, so definitely where those angles meet, that's where your P is going to be located at. So I think it's actually clear. So that was our diagram, guys. Clear and straightforward. Yeah, so let's see the other question. Construct the bisector. Now the bisector of PRQ. Bisector means you are bisecting. What are you bisecting? What is PRQ? PRQ is an angle. So you bisect angle R, that is what it means. So the bisector of PRQ, okay, this is PRQ. So you're bisecting this angle of 60 degrees. So how do you bisect an angle? Just like what we did on 45 there, how you bisect, remember you have to mark two arcs on the lines that are creating the angle. So you're marking on PR and on QR here. So I'm just going to mark an arc. So as you can see, let me just put it somewhere here. Let us mark our arcs. I'm going to take this arc here and another arc here on this side like this. Okay, on those two arcs that you have marked, you have to join, you have to mark from those arcs now an arc which is inside the shape where you want your 30 degrees is going to be, because you are bisecting 60, so definitely it's going to be 30, 30 like this. Okay, from this point again, you mark your arc here. So as you can see, they are going to join, and where they join, that's where we are going to have our 30 degrees from. So from this point, you are going to have our 30 degrees. I don't know, guys, if it is going to be clear, but I just hope we are together there. So something of this nature here. So guys, this is actually difficult actually to work with, but yeah, as we move on and be revising and be doing these things, actually we'll be able to maximize even on the performance. We just hope we are together, guys. We are together here. All right, so at this point here, now I'm going to join. So here I'm just going to use another ink, like a red one, okay, like this. So that's our bisector. We have bisected angle R is being bisected. Okay, the other statement, what are we given? Measure and write down the length of PR. Okay, so this one we just need the length of PR, and this is item what? Item 3. So this is item 3. You just measure your length, then you write down the length of that PR. Okay, so this is item 3. So PR is going to be you measure, but here now I don't know if it is going to give me something exact, because remember, guys, it's not exact here, but we just have to see. But there I got something like 5, is what, 5,8, 5,9, yeah, something like that, 5,8, 5,9. I don't know what you're going to have, 5,9, something like that. Okay, so this is 5,9 centimeters. So it can be 6 centimeters, it can be 5, as long you measure exactly what you got on your diagram. Do not do otherwise. What you got on the diagram exactly as it is, that's what you're going to have from there. Okay, so we have managed to measure our length, that is our length there. PR. Then the other question now, calculate the area of triangle PRQ. Now we need the area. Okay, how do we calculate the area? This is item 4. So remember, guys, area of a non-right angle triangle is given by half AB sine, because this is a non-right angle triangle, so it's half AB sine theta. Why are we using this formula? Because if we are given two sides here, because remember, we measured PR here and got 5,9. So this is 5,9 centimeters. And we've got an angle of 60 degrees here. So this is what you're going to use. So area is going to be half of A and B, which is 8 times 5,9. So it's 8 times 5,9 centimeters times sine theta, which is the angle that is in between. So you're now back to your solving triangles there, guys, when you calculate the area of a non-right angle triangle. Okay, so from there, guys, you can use your calculator. Half of 4 here, half of 8 is 4. So you can just use your calculator. 4 times 5,9. So this is 5,9, which is going to give us 23,6. So 23,6 times sine 60 degrees. That means it's going to give us what? 23,6 times sine 60 degrees. Make sure also your calculator is in degrees. So this is 60 degrees like this. And if we change this to a decimal, it's going to be 20,438, something like that. 20,438, something like that. To the last digit, you write everything. Then you can round off to 3 significant figures. That's 20,4. So it's going to remain as 20,4. So this will be 20,4 square centimeters. Remember, these are centimeters, so your area is going to be in square centimeters, just like that. All right, so that was the condition on this one. Let's see the other part. What are we having? Describe fully on the B. Describe fully the locus represented. Take note, this is a locus. Locus, guys, it's remember, you're supposed to use those. I gave you about 4 loci that you're supposed to know in your syllabus that are very, very important. To describe there, you're supposed to give a loci that you, a locus from those loci that you have, you just put one that matches with the part that you're given. This is a bisector of an angle. Remember, guys, I told you whenever you're bisecting an angle, it means you're talking about line PR and line RQ. So this is locus of points equidistant from these two lines because you bisected angle R here. So that is how you describe this locus. So you're saying it is the locus. So it is the locus of points here. It is the locus of points equidistant from, so this is gonna be from PR and RQ like this. All right, so it's a locus of points which is equidistant from two given lines. And what are those lines? The lines which you bisected the angle R. We're talking about angle R that you bisect. So we're talking about line PR and line RQ or QR, whatever that you're going to have, as long it is PR. So it can be RP and QR, or it can be RQ, whatever that you're going to have, but make sure that this R here is being repeated. The R has to be repeated. Okay, so that was it, guys, on constructors. You can see 12 marks for that, just these 12 marks. Okay, anyways, it was fine like that. Number 6A, solve the equation. It's a quadratic equation that you're given, giving your answers correct to decimal places. So quadratic equation, guys, we must think of the quadratic formula. Definitely here we must be thinking of quadratic formula or completing the square. So because of time, guys, I'm not going to focus on the completing the square method. I'm just going to focus on what you're already used to. But if you want to know more about completing the square, just search completing the square at Mason African Motives. You'll see the topics that I've done on completing the square method, so that you can also opt that method if you want to use that one. Okay, so from our quadratic formula, we just need to apply our formula here. What does the formula say? X is equivalent to minus b plus or minus the square root of b squared minus 4ac. I told you guys this division has to cover everything from where the minus b is starting up to the end of what, of the square root there. So now you can substitute our values. Our a in this case, that is the coefficient of what, of x squared, because we're supposed to have our equation as ax squared plus bx plus c is equal to 0. So our a in this case, that's 3. Our b, that's -5. Our c, that's -7. In this order, a x squared bx plus c. Okay, so that means x is equivalent to -b. So it's a negative on the formula, but our b is also carrying a negative. So you write it as minus. This first part has got a mark of just substituting your values on your formula. So make sure you substitute them properly there. So it's b squared, our b is -5. So it's going to be -5 squared minus 4 times a. Our a is 3 times c. Our c is -7. Okay, everything over. So it's going to be everything that we have there over 2a. So it's 2 times a, of which our a is 3. All right, so from this part, we can simplify minus and minus, that's a plus. So it's going to be 5 plus or minus the square root of. So what I want you to do is to simplify this part under the square root only, without the square root, but the part under the square root. So what I'm trying to say, we're just going to simplify this part, -5 squared. So open bracket, put a minus, -5 squared minus 4 times 3 times -7, like this. So you're going to obtain 109, everything over 2 times 3, which is 6. So from this part, guys, we can actually separate this because we're now having a single square root. So you can have x being equal to 5 plus square root of 109 over 6, or another x which is being equal to 5. Now we are separating because this is a plus or it's a minus. So we are now separating the other one now to be a minus. So to be 5 minus square root of 109 over what? Over 6. There's no need for us to know what is square root of 109 or this and that, guys. We want an answer at this stage. You are supposed to write an answer. It's not about showing, to say square root of 109 is equal to this, and now you end up now having a lot of errors because you're having a lot of numbers there. Use your calculator properly. 5 plus, okay. So if you're using this type of a calculator, it's direct, but I'm just going to do it the DAL concept, because most of us guys, we use DAL. Most of you guys, you've got DAL. So I'm just going to do it the DAL way. This is what you do. You open a bracket, 5 plus square root of 109. So you put the square root of 109 on your calculator. You close that bracket on your DAL calculator. Then you divide by 6. Exactly this presentation that you see on this calculator is the presentation that is supposed to be on your calculator, direct as it is. So this is what you're going to get as a decimal, 2,57, something like that. Okay, so you're going to obtain 2,57. 338, something like that, up to the end. So what you need, write all the terms as they are up to the end. If we do this on the other part, what are you going to have? Just inserting a negative. So let us just change here, remove that and put a negative. You're going to have negative 0,906, something like that. Okay, 906 up to something like that. Okay, then let's get back to the degree of accuracy, because you're supposed to answer according to the instruction that you're given, giving your answers correct to 2 decimal places. So to 2 decimal places, which means you're talking about 2 digits after the comma. So our x here is going to be 12, which is going to be 2,57, or x is going to be negative 0,9. This 6 is going to change this 0 into 1, so it will be 91, like that. Okay, so these are the 2 possible values of x that we are going to have at the end from this question. All right, let's see this part now that we are given. Actually, this would be like a bill, you know, those telephone bill, or it can be a water bill, electricity bill, something like that. That is how it is presented like this. So we are given that the statement above shows a telephone bill for Mr. Banda for the month of July 2009, something like that. Okay, so we're given, or maybe those who are doing accounts, balance brought forward, something like that. This is your balance brought forward to say you had a certain amount of money that you're supposed to pay in a previous month. You couldn't manage to pay that money. So it is going to be the balance brought forward. So this is your balance brought forward, which is the amount in US dollars, 529.74. Then you've got interest, something like that. So this is your table, and yeah, you can just take from there. So let's see. First question. Calculate the interest on the balance brought forward, which means we are talking about interest on this BF, which is item 1. So the interest is going to be what? So interest you're already given here. The interest you're already given. Interest at 2,5%. So this is 2,5% of what? Of this amount. Because we couldn't manage to pay, so we're going to be charged a certain interest. So it's 2,5% of this amount, which is $529.74. So what does it mean? Remember, to remove percentage, you just divide by 100. So it's 2,5 over 100 times $529.74. So on your calculator, guys, if you have to do this properly, you're going to obtain something like 13.2435, something like that. But this is money. Whenever you're dealing with money, remember the cents, 2 decimal places. You're supposed to have 2 decimal places after the comma. So this is going to be $13.24. Okay, so that was the interest here, which is $13.24. Okay, then we move on to the other part, which is item 2, the subtotal 1. So the subtotal 1 here, which is this one that we see. The subtotal. So this subtotal 1, we are saying we are supposed to pay this amount. Then we are now charged a certain interest. What is going to be the total now? You add. So this is for the previous month. We are still in the previous month, but you're given an interest for that month. So you add these 2. That is the balance. That is the subtotal. So it is going to be what we had, 529.74 plus the interest that was being charged of 13.24. So from there, you can actually use your calculator to simplify. So you've got a 529.74 plus 13.24 like this. So it's going to give us 542.98. Yeah, 542.98 Okay, so this is what you're going to have, $542.98 like that. Okay, then we have got the rental from 010709 to 3107, whatever, $10. Then the metered units, the previous reading, the current reading. Take note of what you're given. So the question now is to calculate on item 3. All right, so now item 3, the number of units used. So guys, this is direct. We can even check here to say how many units were we having in the previous month. The previous month, we had these units. Now, currently, these are the units that we are having. So what are the units? We just subtract this 559 26 minus the previous one, which is 55778. So it's current minus previous. Just like when you receive a bill today, for you to know the unit that you subtract the number of units that you see now minus the one that were there last month. That is how you see the number of units that you used. So if you do this, you're going to obtain 148 units. So that is the number of units which were used, okay? Item 4, the cost of 1 unit. What is the cost of a unit? We are saying, since here we are saying these are 148 units which were being used. These 148 units, it corresponds to this amount. This is the amount for these 148 units which were used. So you can take that as an advantage to say 148 units gives us an amount of $31.08. That is the amount. But what about the amount that we have for a unit? What is going to be a unit equivalent to? So you do not know what is going to be the unit equivalent, but as you can see, definitely is going to be less. So for us to find the amount of this unit is going to be 1 over 148 times $31.08. Okay, so if we do this, if we multiply together, we are going to obtain, let's see here, 1 over 148, whatever that you get here, you multiply to 31.08. And that's something like 0.21. So this is direct, $0.21. So that was the cost. Each unit was costing $0.21. Okay, the other part, which is item 4, this is the total amount due. So what is this guy going to pay at the end? This is the amount due that we see here, this amount due here. So what comprises, or what is a combination of this amount, or of this amount due? We are going to take the subtotal one, because remember the subtotal one, it consists of the balance brought forward and the interest. So this is what you're going to take. Also rental, because rental, it's a fixed amount that you're going to pay, whether you go to work or not. This one is a fixed amount, which is $10. Then if you are to cross check here, there is a subtotal 2 that we are having here. This is your subtotal 2 that we are having here. Just like you are now saying, okay, so instead of taking this rental, and we are just taking the subtotal now. Okay, so this one, there's no need for us to take the rental because it's involved on the subtotal 2. So do you see what happens here? This subtotal 2 that we see, it consists of this $10 plus 31. This is the one that gave us 41. So we're going to take subtotal 1, subtotal 2, and the VAT. Remember, VAT is a value-added tax. It's a tax which is added from whatever you're going to have. You're going to add the tax also. So it's included. For us to have this amount due, we are going to work with the subtotal 1, subtotal 2, and the value-added tax. So those are the ones that we are going to combine. Okay, so if we add these guys, our subtotal 1, our subtotal 2, and this tax that we have, we're going to have something like 590.22, 590.22. So that is the idea there. Subtotal 1 plus subtotal 2 plus the value-added tax. You're done. So it's going to be $590.22. So that was the idea of this question. Okay. Anyways, we are going to continue on the other part. Let us see the other question. Let's see question 7, which is actually on transformation. So let's see this transformation. So this question 7, we are given that answer the whole of this question on a sheet of graph paper. So this is what you are given. Triangle KLM is vertices. So these are the vertices, guys. I told you, whenever you're given vertices, just mark on your vertices on the diagram, everything. So you're asked to represent using a scale of 2 centimeters to represent 1 unit on each axis, which means both Y and X. Okay, so you're going to draw and label triangle KLM. That is 1 mark for you to draw that triangle. B, a single transformation maps KLM onto triangle K1, L1, M1 with vertices. These are the vertices. Draw and label. So as you can see, the first part was for drawing the 2 triangles. Okay, so mark your points properly. Then you can actually join, just like what I did here. I have my 2 triangles. KLM and K1, L1, M1. So these are the two triangles that I'm going to work with. Okay, so from these two triangles, what is the question about? The question is, describe now on this item 2, the single transformation, which is the one that mapped triangle KLM onto K1, L1, M1. So as you can see, this is actually our image, and KLMN is our object. So this is your object here. So if we are to let's see the condition that we are given of the question. The two triangles, as you can see, guys, these are isometries. As you can see, the object, which is in red, and this image in blue, they're actually congruent. They are the same. So our answers here, remember I told you, if they are congruencies, you're going to expect to have these two answers, three answers actually: rotation, reflection, and translation. But which one is the best answer there? Okay, this is what you simply do. Remember, for you to know this, you have to join corresponding elements. So actually we need our ruler so that we can, but here we don't actually need, but let us have it, but it was actually clear. I want you to see what is, because these points, they're actually on a straight line. So there was no need for us having this. If you can see M to M1, it's actually a straight line. Okay, but anyways, for the sake of all of us understanding what is happening here, I'm just going to join these points M to M1, and also K to K1, like this. This is our K to K1. We also, we also join L to L1, like this. We join these points L to L1. As you can see, they're actually the same. Okay, so what are you having at the end? These are parallel lines which are being produced, but they are not of equal length, because yes, these two are the same from K to K1, L to L1, they are the same, but M to L, just look at this distance, guys, from M to M1. It's not the same as K to K1. So that means rotation is no longer there, because rotation, the lines has to cross. Translation is no longer there, because under translation, you're going to have parallel lines of equal length. All these lines, they are going to have equal length. So which means you are left with reflection. That is the one that produces parallel lines of an equal length. So we can now describe to say this is what? A reflection. So this was actually item 1, item 2. Is it B, item 2? So we're going to describe now, it is a reflection. So this one is a reflection. So it is a reflection. And what do we need on the reflection? Remember, guys, reflection, you need the equation of mirror line. So equation of mirror line. So the equation of mirror line, guys, I told you, you bisect any one of the corresponding lines. But here we can even see that they are bisected throughout. X is equal to -3 somewhere there, if I'm not mistaken. Is it 3 or minus? I don't. Let us do it. So you just bisect any one of these corresponding lines. So I'm going to bisect line M to M1. Okay, so I'm going to use M to M1. So you just bisect any of your choice, any corresponding line. It's not like a force matter to say, okay, you're supposed to use this point. No, you just bisect. Like, remember, to bisect a line, guys, you open more than half of the line. So like this, I'm going to open more than, actually I'm at more than half. As you can see, I have to construct an arc on top here around this, okay, on top here, and another arc down here. The same way that you used to bisect on your construction. You do the same from this M1 here. On this M1, I'm going to change this side, construct an arc again. On this side, you construct an arc again. So as you can see, these arcs, they are going to meet. We are focusing with these arcs here, which are in black, this one and this one. These are the arcs that we are talking about, this one and this one. So as you can see, they meet, and you can join them. Now, by joining, we are finding the line which here to what? To map one triangle to another. That is the idea there. So what you're going to do, guys, they are going to be actually in between, directly in between somewhere here. Okay, and which value is this one, guys, that we are seeing here? Okay, how many boxes? Let us just join and see exactly where it is going to be located. Something of this nature here. All right, or maybe let me just increase this side so that you can see, because our diagram was actually going to be on top because of the map of this scale that you're given there. Okay, something like this. Okay, so it's not actually at -3, but this is going to be like in between these points here. How many boxes do we have? Let us count the boxes and see if truly we are having the same thing. This is our M or K1, which is one box here, and we move from K to this, which is one box again. Okay, we are going to have one box here. So this point was supposed to go somewhere here, guys, in between, directly at -3. Okay, -1, -2. It was supposed to be directly at -3 there. That's where we're supposed to have our line there at -3 here. So it's supposed to be there because this is one box and also one box. From M here to this box is one. From M to this is one. So it's in between those points. Okay, 1, 1. So it's 1, 2. From K, just cross check our points, guys. I think one of these points actually not the same. One here, 2. All right, so one of these points is actually not the way that you have. It's our M1 here. Our M1 is actually -2, 4. -2, it's here. This point is here, guys. Okay, so actually this point is here. I was wondering actually what is happening. This M1 that we see here, supposed to be here, -2, 4. It's here. That is where it's supposed to be. Okay, so I want you to join up and see, but if you had to see, it was supposed to be like this way. Okay, so this one, it actually shifted. I actually marked this point a little bit. It was supposed to be like this. Yeah, now it can make sense. So it was going to be at -3. So that one, like I said, I want you to correct that one and see. It's going to be accurately done. So it was going to be at -3. So the equation of mirror line is x is equal to -3. So it was going to pass direct at -3. Okay, so actually, these are things that you can use also in exam to prove, are you doing the actual thing or not? So do not just draw, just write. Okay, so anyways, guys, cross check on that one. So the M1 was supposed to be directly at -2, 4, not there. It was just a little bit from there. You know, guys, when you're dealing with these graphs, these boxes, this and that, it's a lot. Yeah, you actually understand when you're dealing with this software, but I hope you understand what happened there. Okay, let us see the other part now. We are given M2 is actually 3 minus 1. State the translation vector. Okay, so this is the image. So now we need the translation vector. So M2 is the image. So we are given the image here. And how do we find translation vector? So we actually know that, so this is our C item 1. Translation vector, I told you guys, is image minus the object. So that is our translation vector. So it's actually image minus the object there. So this is image minus object. So what does this mean? I'm just going to take the image point, this one. This is our image, M2. So it is going to be M2 minus the object, which is M. But you write it as a vector form, okay? Like a matrix, that's vector form. So it's 3, 1, 3 minus 1 in vector form minus point M. Our M here is -4, 4. So this is your M, -4, 4, like this. All right. So from there, we can actually simplify further, and that means we are going to have our 3 minus -4, which is going to be a +7, -1 -4, which is -5. So take note here, minus and minus a plus. So this is our translation vector, which was going to be 7 negative what? 7 negative 5, okay? Then from that item now, they are saying write down the coordinates of K2, L2, the images of K, L, respectively under this translation. So now what do we have? We have got the translation vector that we got here. We want to calculate the images, okay? So remember that, so I'm just going to work it aside here. This is our item 2 from C. So from that formula that we have, we say translation vector is equal to image minus object. This time we want to find the image, so I'm just going to take the object to the other side of the equation. So it means translation vector plus the object is supposed to give us the image now, since we want to calculate the image. So what does it mean? The image of every point that I'm going to have is going to be the translation vector added to the what? To the object. So that is what you're simply having from this part here. So what am I going to do? I'm going to take the corresponding point. So many say the image here, we are talking about what? Write down the coordinates of the image, which is in this case, we are referring to the points K2 and L2. These are the ones that we are going to use in this. So that means in this case, we can actually find our K2, our L2 here. Okay, so K2 is going to be, the image is K2. So the translation vector is the one that we got here. Remember, we have got our translation vector, which is 7 minus 5. All right, so it is going to be the translation vector of 7 minus 5 plus the object. If you are dealing with the K2, the object definitely is K at that moment. So we're going to add the coordinates of point K, of which we have got the point K here. Originally, our K was minus 5, 3. That was minus 5, 3. So we are going to add minus 5, 3, like this. All right. So the moment you add this, you are going to have the image, which is what? Which is K2. So 7 plus minus 5 is 7 minus 5, which is 2. Minus 5 plus 3, that will be minus 2. Okay, so this is our K2, but we are supposed to write this as a point, because these are the coordinates. So K2 as a point is 2 minus 2, like this. You write it as a point, not like this. This is a vector, but when you are writing now, you have to write it as a point, like this, 2 minus 2. You do the same because it's not about K, but it's also about L2. So we also need L2. So that means L2 being the image is going to be equal to what? L2 is going to be the translation vector, the one that we had here, which is 7 minus 5 plus the object. The object now is L. We are talking about L2, so the object this time is L. So we need the coordinates of L. And the coordinates of L here is minus 1, 2. Those are the coordinates we're having, minus 1 and 2, like this. So you can actually add 7 plus minus 1 is 7 minus 1, which is 6. Minus 5 plus 2, which is minus 3. So these ones, I don't expect you to fail because you are having calculators. You can use your calculator there. So L2 as a point is 6 minus 3. We are now writing as points. Remember, a vector like this, it carries x, and this is your y. Remember, your vector concept is x and y like that. So which means it is going to be 6 minus 3 as our L2. All right, then D, triangle KLM, which is that object that we have before, is now mapped onto another triangle, which is called K3, L3, M3 by a shear. Take note, this is a shear of factor 2 with y-axis invariant. Write down the matrix for shear. Guys, we've got two matrices for shear from the Locus concept. We have got a Locus like this one, and we've got a Locus from this way, Locus like this. Which one is for the y-axis invariant? So for the y-axis invariant, we are talking about the y-axis not moving. This is your y-axis not moving, 0, 1. Here it's x-axis not moving. So it's x-axis invariant, but this one is the one for y-axis invariant. But remember, the k represents the shear factor, so it's going to be 1. In place of k, you substitute the shear factor now, which is 2. So it is going to be 1, 2, 0, 1, like this. That's your matrix for shear there. Okay. Then from there, after having your matrix, draw and label triangle K3, L3, M3. So how do we draw to the triangle? Remember, guys, that matrix times object should give us what? Should give us the image. That's what you're going to have in this case. Okay, so we're going to have matrix times object is equal to image. So which is the matrix? This is your matrix that you are given here, 1, 2, 0, 1. That is our matrix, times the object, which is the original triangle KLM. So which means you are going back, write these coordinates as they are, KL and M as they are in that order. Okay, so we are going to have our K here, our L, and our M, but you just write them in what? In matrix form. So this is what you're going to have. So our K, you write it in point form, and our K was actually -5, -5, 3. Our L is -1, 2. Our M, which is -4, 4. Okay, so that's what you're going to have at this moment. And from this condition, what are you going to do? We have to multiply. Remember, guys, matrix multiplication, row by column. So that's what you're going to do here. Row by column, each and every column separated. Okay, so let's start with the first one. 1 times -5, that's -5. All right, sorry, let me just change these two. Okay, so it's 1 by -5, which is -5 plus 0 times 3, that's a 0 here. 1 times -1, that's -1 plus 0 times 2, which is a 0 here. 1 times -4, that's -4 plus 0 times 4, which is a 0 here. We are done with the first part. We move on to this row now versus those columns that we had before. So it's going to be 2 times -5, which is -10, plus 1 times 3, which is 3. 2 times -1, that's -2, plus 1 times 2, which is 2. 2 times -4, that is -8, plus 1 times 4, which is 4. So from this part, guys, we can collect our like terms together. I mean, we can just combine, not collecting like terms, actually, just combining here. -5 plus 0, that's -5, -1, -4. Okay, -10 plus 3, that's going to be -7. -2 plus this one, that's a 0 here. This is -4, if I'm not mistaken. So with these points, we can now say these are our images now of that triangle that we're given, which is referred as K3, L3, M3. So what does it mean? It means our K3 as a point, that's -5, -7. Our L is KL, yes, so it's L3, which is -1, 0 here. So what I'm trying to say, remember, this is your K3, L3, M3, but you're now writing as what? As points now. That is what you're simply doing. And the last point, which is M3, is going to be -4, -4. So using these coordinates now, we are going to take these coordinates on our graph. Then we can draw our graph, our triangle. So K3, it's -5, -7. So -5, -7 is down here. Right, that's -5. -7 is actually down, guys. Down, 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 down here. Okay, so I'm just going to mark. I hope it's clear. -5 here versus -7. So it's going to be down at this point. Okay, so that's where we're going to have it as our K3. So this is our K3. And L3, that's -1, 0. So this is -1, 0 somewhere here. X is -1, Y is 0. So -1, 0, that's here. So that's where we're going to have our L3 and our M3, that's -4, -4. So -4, -4 is somewhere here. X is -4, Y is -4. Where these two meet, -4 here and this -4, they meet at this point. Yeah, let's just, it's fine. Because here, guys, you remember, there'll be too much light, so I won't be seeing that properly, but that will be our M3 now. Here. So definitely we have to join these points and let us see how weird is this diagram. Okay, let's see how this diagram is gonna look like. Okay, so I'm just going to join these points so that we're going to see how it was going to be at the end. Okay, so here, just join your points here. All right, so this is what you're going to have at the end. Yeah, we can just join from K3 to M3, depending with what you're going to have. Then we can do that on the other hand. All right, so we need to join from L3. Remember where our L3 is located, guys, back to what? Back to K3, which means we are talking about something of this nature. All right, that's where our K3 is located at. All right, so just join that, yep, okay, something like this. And you can join to M3 from this K3 to from L3 to M3, just something like this, guys. It's not gonna be that accurate, but somewhere here like this. All right. So after joining, what are we seeing? Look at the triangle, how it's going to be big like. So actually it's a shear, that one, as you can see how our diagram is looking from the original one. This is how it's going to look like. So actually that one, that's a shear. So if you are given shear, guys, you are simply putting in your points. That is what you are simply having. Put in your points, then from those points, join. If you're given matrix, use your matrix just like that. As you can see, guys, you see, advantage of working with matrices, your diagram becomes neat. As you can see, we have less diagrams, less calculations here on our diagram because you are using matrices. So I urge you guys to know your matrices of transformation. Transformation becomes one of the easiest transformations, one of the easiest topics that you're going to have actually if we are dealing with this topic. So I think this part is actually clear. All right, so that is the idea that you're going to have, guys. If you are given this condition, all you need is to work from what? From the information or from the matrices that you're going to have. Make sure that you understand your matrices of transformation, like this one that we had. It was actually 12 marks for you can't say for nothing, but it was actually 12 marks that was easier for us to work with. Okay, number 8. Answer all of this question again on a sheet of graph paper. A newly constructed school wishes to buy desks and chairs for its pupils. Let X be the number of desks and Y be the number of chairs, okay? So let us say it, our X is going to represent the desks that we are going to have, and Y is representing the number of chairs that you are going to have. Okay, so the school wishes to buy at least 75 desks. So remember, guys, I told you at least means greater or equal to. So write down two inequalities. So X here is for the desk, because the desk is what? 75. So it's at least that's greater than or equal to 75. And at least 100 chairs. A chair is represented by Y, so Y is greater than or equal to 100. We've got two inequalities, just like that. 2 marks, just write this, guys. Okay, the number of chairs should be more than the number of desks. So the chairs are represented by Y, and the chair and the desk by X. So they are saying Y is supposed to be more than. So more than means greater than. That's greater than X. Just like that. Not equal to, they are greater or more. So it's supposed to be greater like this. That's a greater than sign, okay? Then we move on to the other part. A desk costs $25 each. A chair costs $17.50 each. The school has only $5,000 to spend on these items. So take note here. This is the only amount that we have to spend, which is 5,000. So there is no way we can use anything greater than this amount. We can use an amount up to that amount of 5,000 or less than that amount. So which means, remember, each desk is X. So 25 by X plus each chair is represented by Y. So it's going to be 17,50 or 17,5Y, supposed to be less than or equal to what? The amount that we are having of 5,000. It can't be greater than that. It can be equal or less than that. You can use only what you have or less than what you have. That is what you actually have here. So, but we are asked to write down an inequality and show that it reduces to. So this inequality has to reduce to this one. How is it going to reduce to that? That's what you want to see. All right, we can start by removing the decimal part, which means we have got one decimal place here. So what am I going to do? Since I've got one decimal place, I'm going to multiply by 10 each and every term to remove this comma. So 25 by 10, that's 250x. 17,5 times 10, that's 175y is less than or equal to 5,000 times 10, which is going to be 50,000, like that. Okay, so you can actually reduce this. I want you to see, you can reduce by 25. Yeah, 25 is common. So you can reduce by 25 each and every term. So that means here we are going to have 250 divided by 25, that's 10x, plus 175 divided by 25, which is something like 7y is less than or equal to 25 into 50, that's 2, and these zeros remain as they are. So as you can see, we are having another inequality, which is this one they told us here. So how many inequalities we have? We've got this one that we have here. We have got y is greater than x. We have got these two inequalities. So we've got 4 inequalities all in all that we are going to use to represent now on this item which is item B, using a scale of 2 centimeters to represent 25 desks. Remember, a desk is what? On X. So they are saying 2 centimeters to represent 25 on the X-axis. That is what we mean here. Okay, on the X-axis, on this one. And okay, let me change to another one. Okay, so this is 25 on the X and 50 on the Y-axis. So this 50 that we see is for the chairs, and the chairs, they are on the Y-axis. So let us see, this is how it is going to look like. This is your X here. So this is your X here. Our X, we said it represents what? The number of desks. So these are desks that we have here. Okay, then the Y on this side, it represents what? The chairs. So this is our Y on this side, which represents the chairs. So this is your Y-axis representing the chairs. Okay, so guys, I told you inequality is direct. Just have to represent the equation of the line, then the inequality after that. So the first inequality, if you saw it, it was X is greater than or equal to 75. X is greater or equal to 75. So we need the line X is equal to 75, and it's supposed to be a continuous line because there's equal to there. Okay, so X is equal to 75 at this point here. That's where our X is 75. So all we need is to just draw a line, and it's supposed to be a continuous line at this point, 75. Okay, so this is what I'm going to have at this point. Draw a continuous line like this. All right. So just draw up to any point that is clear. At least it has to be a little big enough from where we are having this point here. Okay, so this is our line, and you write down the equation of the line, just even along the line, X is equal to 75. And we don't know where to shade. So as you can see, guys, we're talking about values which are greater than 75. So we are talking about values such as 100, 125. These are the ones that we need. So we are going to shade this side, the unwanted region, which is the side that is less than 75. All these values, they are less than 75. You shade them according to X. All right. So that was actually the part of the question. So you have to be very, very careful, guys, on this part. Okay. Anyways, let us see. The other part, you can shade up to any point of your choice. Just have to shade there. Okay. Then the other one was Y is greater than or equal to 100. Remember your equation, your inequalities, Y is greater or equal to 100. So we are going to draw the line of Y is equal to 100, and it has to be a continuous line again. Okay, Y is equal to 100. Where is the point? This is where we are going to have our Y being equal to 100 at this point here. Y is 100 there. So that means we are going to join from this point of 100, let it be a continuous line. So just about a continuous line at this point. All right, a continuous line, that's 100. So we are saying this equation here of the line is Y is equal to 100. But let us get back here. Y is greater than or equal to, which means we need values which are more than 100, like 150, 200, they are more than these values 18, 200. This is actually 250, something like that. Okay, so this is what you're going to have, something like that. All these values are greater than. Okay, so which means you're going to shade this side, which is below 100. This is the side that you're going to shade. All right, so you can shade this side. That's less than 100. Okay, then we move on to another one. It was Y is greater than X. So Y is greater than X. What does it mean? We have to draw the line of Y is equal to X. So remember, guys, I told you for this one, it means it's the same. When X is equal to 0, Y is also equal to 0. When X is whatever value that you're going to have is the same as the Y. Okay, so if X is 50, it means Y is also 50. If X is 100, it means Y also 100, because Y and X, they are equal. So you can mark your points 0, 0, 50, 50. All right, so this is going to be 0, 0 here, 50 versus 50. So this is 50, 50 here, 100 versus 100 here. So this is how our line is going to be. So take note, because of the scale that you're given, and this one is a broken line because Y is greater than. Remember, guys, your inequality signs, You're supposed to have a broken line there. Okay, so anyways, let us have our broken line from those points that we have. This one, 0, 0, 50, 50, 100, 100, like that. So you can join using a broken line. So I'm just going to have a broken line here. Oh, sorry. Supposed to be somewhere here. Okay, so this is how it is going to look like. All right, then from this, you are supposed to write down the equation of the line. Just as usual, guys, you write down your equation of the line. Y is equal to X. Okay, which side are we going to shade now? Let us look at the line, how the line is presented. Our line is like this, and we are saying greater than. Remember, guys, I told you this is the greater side, this is the lesser side. So greater than X, we're talking about this side on top. So we do not want this side, which is below, because we want a greater side, not a lesser one. So we're going to share this side. So which means we are going to share this side here. All right. So from Y is equal to X, this is the side that you're going to shed here. Okay, just like that. I think you can understand from the inequality graph that I did. I actually talked about two ways that you can use using points or just looking at the line. You can see, okay, this is the side that I'm going to shade. So you can use this or the other way. Okay, let us cross check the other one. It was, we remember we reduced that inequality. The last one, it was actually 10x plus 7y. Which is less than or equal to 2000. So this one is supposed to be a continuous line because there's an equal to there. But for this one, it was easier for you to have a table of values. But this table of values, you just pick, guys, any 3 points of your choice that you're going to use. But in this case, guys, I'm just going to work with 2 points. Okay, I'm going to choose my x to be 25. And another one to be 200, my x to be 200. Does it make sense? Okay, if my x is 200, okay, let's see. If x is 25, I'm going to substitute here. If x is 25, it's actually 10 by 25, which is 250, because our x is 25. So it's going to be 250 plus 7y is equal to 2000. So let us find the value of y. I'm going to transpose the 250 here. That means I'm going to subtract 2000 minus, so it's 2000 minus 250. All right, whatever that I get, I have to divide by 7 because there's going to be a 7. So I get 250. So y is going to be equal to 250. So this y here is 250. Okay, what about if our x is 200? So this one is now 200 here. So it's 10 times 200, which is 2000. So it's going to be 2000 plus 7y is equal to 2000. So as you can see, if we transpose this 2000 there, it is going to be a 0. 2000 minus 2000, then divide by 7, y is going to be 0 there. Okay, so these are the 2 points that are enough in this case. 25 versus 250. All right, so we've got 25 versus 250 here. Okay, so this is 25. 250, this is 200, 250 here, so 25 versus 250, you mark your point. Another point, we said when x is what? 200, y is 0, so we need 200, 0, which is somewhere here. X is 200 and y is 0 at this point, that's 200, 0. Okay, and our line, we said this line is supposed to be a continuous line, so we are going to join now those 2 points. They are enough in this case. Then with these 2 points, let this graph be a continuous, like this line. Let this line be a continuous line so that it can actually help us to illustrate exactly what we need here. Okay, so just a little bit, guys, a little bit again to this point somewhere here. Okay, so I'm just going to adjust, okay, somewhere there. So all you need is to join properly the given points that you'll be having in this case. Okay, I think if I can do this a little bit, because now it's not giving me exactly what I need here. All right, so somewhere there, I think it's actually fine now. Okay, just join, okay, because of time, guys, something like this, a continuous line, okay? Then which part are we supposed to be having, or which part? Look at the line that you're having. This is a slanted line like this. Okay, so our line is like this. This is how our line is drawn. Okay, remember I told you this is the bigger region, the lesser region. So the question is, less than or equal to, which means we need this region. That's the lesser than region. We do not need this one. So we're going to shade the top part of the line. We do not need this part, sorry. So we are going to shade the top part, which is this one on top here. This is where we are going to shade. We do not need this region. And also don't forget to write the equation of the line also. All right, so I think just to save a little bit. All right, so I'm going to share this side. And like I said, do not forget to write down the equation. Remember the equation was 10x plus 7y is equal to 2000. That's the equation that you're going to have. Okay, then from there, guys, as you can see, we have got a region which is left, which is not shaded here, or this part is being shaded. All this region is shaded, all this, but this region is not shaded. This one, as you can see, this region which is in between. So that is where your answers are going to be taken from. Whatever that you're going to answer. Remember, guys, I told you it is going to be taken from that region. But here, because of these things that are not like exactly to the point, but that's where your answer is going to be actually taken from this region that you see here. You see? And do not take anything that is from what? From a broken line. Never take anything from, you take from continuous line, which means you're talking about this point, and here this is the point that we can, because this one is on a broken line, so we are going to take this one, not anything here. We are not going to take anything on this line because it's broken. All right, so whether it's a broken, then a continuous we don't take, we just take on continuous. So we got 3 points, this point, and this point. Those are the points that we are going to use to answer any question which follows there. Okay, so that is the case whenever you're dealing with what? With this part of what? Of inequalities, okay? The diagram shows an athletics running track enclosing a rectangle field. Okay, where is the diagram? Okay, the diagram is not there. Okay, so this question does not have the diagram actually. I don't know what happened on this canvas because the diagram is not there. Okay, so we're going to see which this no longer is not even there. Okay, anyways, let's see the 10 part. Question number 10, we are given OA BCD is a pentagon such that AB is parallel to OD. Okay, so this is a pentagon and this side they're parallel OA and AB, or it's AB and OD, these two lines there. So as you can see, according to the diagram, if you can, these lines, guys, they are not parallel, as you can see, but we are told that they are parallel, so we don't fight that statement. We have to indicate, okay, we said these are parallel, okay, so it's fine. So these two lines, they're parallel to each other, and M is the midpoint of OC. So this M that we see is in between OC, so which means from O to M and from M to C, there is equal distance. That is what it means. And AM produced is going to meet at what? At X, like that. And they are given vector OA, which is A, and OD, from O to D, it's B, which means this B that we see is the vector of O to D. That is the one that you're talking about there. All right, so that is the idea. And OD is equal to 3XD. So if we are given a ratio of OD, which is equal to 3x, what does this part mean? Actually, it means if this OD is equal to 3XD, we have got this or XD that we see here, which means we've got one XD that we see, it's only one here. And in OD, there are 3 of them, which means from this O to D here, like this. All right, this is our O, D, and this is our X, which is this one. From X to D, this is XD, which is 1 XD. But we are being told from O to D, this one, there are 3 of them. So here we have taken 1 XD. So we're going to remain with the 2 from X to what? To O. There are 2 which are remaining here. So that 2 plus 1 gives us what? Gives us 3. All right, so that becomes an advantage to answer any question. Okay, item 1, vector AD, in terms of A and B, what is going to be our vector AD? So we just need a route that we are going to take from A to D. From A here to this point D, so it's going to be AO plus OD. So that one is AO plus OD, which is from A to O, we are opposing the arrow, which gives us a negative, plus O to D, which is a positive B. Done. All right, what about OX? So from O to X, we are going to Do you have a route that you're going to take? We do not have, but we can actually use this ratio here from O to X, because we said from O to X is 2 parts, as you can see here, from O to X is 2, and this is 1. So OX is going to be 2/3 of OD. That is what it means, 2/3 of OD, which is going to be 2/3 of OD. What is our OD? From O to D, remember, that's vector B. So it's going to be 2/3 vector B. Okay, that's our OX. What about AX? So AX is supposed to be a continuation from the OX that we are given there. So actually for vector, guys, if the first equation and the second equation are confusing you, if these questions that you see here are bringing confusion to you, these 3 questions, do not answer that question of vector. Leave it. Move on to another question. Leave it like that. Because whatever that you're going to have is going to be taken from these questions. So it's a waste of time. You're wasting your time. Wasting your time. So whenever you see that one happening on vector, you don't understand what is happening, especially on your ratios or this part. Once that confusion is there, leave that question. Move on to another one, because it's going to be a waste of time to answer that question. Okay, anyways, AX, which route are you going to take? Since we have got XD, we are going to, we have got OX here, we are going to take from A to X is going to be A to O, then O to X. So this one, AX is going to be from A to O plus O to X. All right, which is from A to O, we are opposing the arrow, guys, as you can see, are going down. So it's a negative A plus O to X. Already O to X, we calculated this one. O to X is 2/3B. So it is going to be 2/3 vector B, like that. Okay, so that was it. Let us move on to the other part, which is item B. On B, we are given that MX is equal to K. Are you seeing what I was talking about? This MX is equal to KAX, of which AX we calculated it here. So which means it's a continuation, which means if this was wrong, this is also wrong. Everything is going to be wrong. So guys, I hope you understand what I'm trying to say. Okay, anyways, so we are given that MX is equal to KAX. Express MX in terms of this. So the first thing is to find AX, which is the one that we have here. So it's a continuation. So since we are saying MX is equal to KAX, what am I going to do? I'm just going to multiply by K, my vector AX. What is our vector AX? Our vector AX is minus A plus 2/3 vector B. So we can multiply by K. K times minus A is minus KA. K times 2/3B is 2/3 KB. Okay, so this is your vector MX. All right. So we are done with vector MX. Let us move on to another item C. DC is equal to HOA. So this is what you're given on DC. So let us talk about this DC, because as you can see, you're asked to find OM, which has nothing to do with DC. Okay, so the first thing is to know our DC. We are given that this DC is equal to HOA. So that means it's H times vector OA, of which vector OA we are given as what? As A. So it's going to be H times A, which is HA. So this is your vector DC. So this one I want you to see and place it on your diagram here from D to C, because we are given that these two are parallel here from D to C. So this DC that we see, it's HA like this. That is what they're trying to say. Okay, anyways, let us see the question. The question is now from this DC that we are talking about, this one, can we find OM? Because it has to be in terms of A, B, and H. And the only part now that carries H is this DC that we see here. That is the only part that is carrying H for the meantime. So it means whatever that you're going to have, yes, or must include the DC from O to M. Okay, so I want you to see from O to M, which route are we going to take? Okay, from O to M here, okay, let me just write my item, I don't know. Okay, even here is fine. From O to M, I have to include this DC, but OM is actually, because remember I told that M is the midpoint. So this OM is actually half of OC, provided that we have got this OC, but we do not have this OC. So that means we can play around to find OC first. So what is our OC? From O to C is going to be OD plus DC. So this was going to give you OD. Or we need vector OC, so it's going to be OD plus DC. All right, of which O to D, that is the one that you're given as B. So this is going to be vector B plus DC. Remember, the DC is this one that we now have, which is HA. So it is going to be plus HA, like that. Okay, of which you can just write it as what? As HA plus B, starting with H, starting with A, then followed by B. So it's still fine. This is your vector OC. But what do we need? We need to find OM, and we say this OM that we are talking about, it's half of this OC. So it means we are going to have it like this. OM, it's half of our OC, which is this one, HA plus vector B. All right, so let us multiply by half. It's half of HA, which is half HA, half times B, which is half vector B. Okay, so this is your vector OM. All right, so I think from this part, it was actually a confusing type of equation. Yeah, this one was actually a confusing type of equation. But anyways, what about mx from there? So mx is a continuation again. So m to x, we are going to use this OM that we have. But which root are we going to take? M to x here, this is m to x. So you can say mo plus ox. Mo, remember guys, here we have got OM, but we are saying MO. Okay, so I hope you understand what happened there. So this is item what? Item 2. All right, so on our item 2, we said we are going to need MX. So the root that I'm going to take from M to X is M to O, then O to X. So this one is going to be MO plus OX like this. Okay, but what is going to happen now is that from M to O, I'm opposing the OM because this is OM, but we are talking about MO. So what do? You simply multiply by negative this term of OM. So it's going to be minus half of HA minus half of B, that is OM. You multiply every term by minus. Okay, so it's going to be minus half HA minus half B plus OX. So here's our OX. Remember our OX, we've got it here. Our OX we calculated before. We said OX is going to 2/3 B. So that's 2/3 B. So it is going to be plus 2/3 B. Like that. All right. So that means it's an advantage because it's just going to be a combination here. Minus half HA. That's what we only have. Then you can combine both. These are like terms. Minus half plus 2/3. Just need your calculator. Here you can just put it aside. Here that's minus a half, minus 1/2. Whatever that I'm going to add 2/3 like this. And that's 1/6 B. So this is going to be plus 1/6 vector B. All right, so this is your vector MX, the one that you're having here. All right, so I think it's actually clear. Yeah, all you needed, guys, was to work on this question. It was actually an interesting question. On the other end, it was a hectic question, but I just hope we see what is happening here. All right, and the D part now, using the values of the results in B and C item, what find the value of H and the value of K. Okay, so what do we have from B? This was our B. We calculated MX. C item 2, we calculated MX. We are saying these MX that we calculated, they are equal. Okay, so this is what you are going to do, guys. Remember, I told you you have to equate those vectors. Okay, so this is D. The first MX that we got from our item B, it was minus half KA. Remember, it was minus KA, not half, but minus KA plus 2/3 KB. That was our MX here, this one. And the other one that we got here, this is our MX that we got, minus half HA plus 1/6 B. So we are going to take that one. Another MX, we got negative half HA, okay, plus 1/6 B, plus 1/6 vector B, like that. Okay, so let us find the value of K and the value of H. Remember, guys, I told you that at this stage, you are going to equate the vectors. We are talking about vector A and vector A. What is affecting the vector A here? It's minus K. So minus K is equal to, what do we have on vector A here? We have got minus half H. We are done on this part. We are concentrating on this. Concentrating on vector B, what is the coefficient of the scalar of this vector? Is 2 over 3k. So it's going to be 2 over 3k, which is equal to here, we have got 1 over 6. So you have got two equations that you have formulated, which are simultaneous equations. But on these two equations, there are sometimes where you've got an advantage to work from, like this one. We can take advantage of the k here, because it's just one unknown on this equation. So on this equation, you can solve for k's. Cross multiplication, guys, I think this one is actually clear here. All right, so if you cross multiply, you have 6 by 2, that's 12k is equal to 3 times 1, which is 3. So to find k, I'm just going to divide by 12, divide by 12. That means our k is going to be 3 into 3, that's 1 into 4, which is 1 over 4. All right, so our k is 1 over 4 from this part. And to find h, now I just need to substitute the k that I got here, because here I've got h and k, so I'm going to substitute here. Minus 1 over 4 is equal to minus 1 over 2h. In place of k, we are substituting 1 over 4. So as we did on the previous part, we can also cross multiply to find our h. That means 2 times negative 2, that's times negative 1, that's negative 2. 4 by negative 1, that's negative 4h. So what do I do to find h? Just divide by negative 4 by negative 4, both sides. By doing this, you are actually obtaining or evaluating the value of h, and this is going to give us 1 over 2. So our h in this case, that's 1 over 2. All right, so on this part, guys, that's what we had. And let us see the other part of the question. Express or using the results of h and k. Now, express in terms of, take note, guys, a and b, vector mx and vector dc. What you do is that you calculated vector mx. This is your mx. We have got this mx here and this mx here. They are in terms of, the other one is in terms of k. The other one is in terms of what? The other one is in terms of k. The other one is in terms of h. So what I'm trying to say is that on this part, we are going to substitute the values that you obtained now to find these exact values, because you only need a and b. But before, it was in terms of what? K, a, and b. So you are going to take, you choose the one that you're going to, are you going to work with the one that has got k or the one that has got h? Okay, so I'm just going to do them and see if truly we are obtaining the same answer. So our first mx, it was minus ka, and our k, we got our k, remember it was 1 over 4. So it is going to be minus 1 over 4a plus our k is 1 over 4, so it's going to be 2 over 3 times 1 over 4b, like that. So 2 over 3, you just need to multiply 2 over 3 times 1 over 4. Okay, sorry guys, sorry for this. I think actually something happened here. I don't know what actually happened. Okay, sorry for this. I don't know. Are we still in this? All right, so actually I don't know what happened here. So we are just going to add, we are just going to multiply here 2 over what? 2 over 3, whatever that you're going to have, we multiply to 1 over 4, just like that, 1 over 4, like this. And this will give us 1 over 6, okay? So it's going to be 1 over 6. So we've got negative 1 over 4a plus 1 over 6b. So this is your mx in terms of a and b. So you can even prove on this one to see if truly is the right answer. Remember your h, you calculated your h, you got 1 over 2. So if you substitute 1 over 2, are you getting the same answer? Let's see. Mx is going to be, this is minus half h. So it's minus half times h. Your h, we said, is 1 over 2. You substitute 1 over 2, which is h times a plus 1 over 6b. What are we substituting? There's nothing. We already have b. There's no other constant. So we just write it as 1 over 6b like this. Okay, minus 1 over 4 is the one that you're going to get here if you multiply properly. So it's going to be minus 1 over 4 plus 1 over 6b. All right, so this was your vector mx. So that is the idea on this one. Then the other one was DC. So DC on item 2 is DC. So you just get back here. We wrote about this DC here. We said DC is equal to HA. And now we have got our A. So which means this DC is going to be H times A. And our H is what? Our H is a half. So it is going to be half A. That is what they are trying to say, because previously your H was DHA or DC was HA, but you've got the H now. So just substitute your H, just like that, you're done. So that was our number 11, guys. That was a number 10, actually. Then you want to cross check on the question 11, which is, let us see what we are having on this part. Number 11, which is a quadratic graph. So we are going to focus on this. All right, so here we are given, answer the whole of this question on a sheet of graph paper, and this is actually what we have. If you are to cross-check, we are given the equation, which is actually an incomplete equation that you are given, which is x and so forth, whatever that you're going to have from this equation. So the question was to calculate the value of P and the value of Q. So here, guys, I told you that it's simply a substitution that is going to take place. In place of x here, we're just substituting -half. So y is equivalent to 2 into -half to the power of 2 minus 5 into -half minus 3, which means y is going to be something like a 0. Okay, y is going to be 0 here, which means that's our P. So we are saying P is equal to 0. Then we move on to Q. Our Q is at a condition where this is 2. So y is going to be 2 into 2 squared minus 5 into 2 minus 3. So if we simplify on your calculator, this is going to give you -5. So which means the value of Q here is going to be -5. Okay, so from that part B, using a horizontal scale of 2 centimeters to represent 1 unit on the vertical scale and 2 centimeters to 2 units or on the horizontal scale, then a vertical scale of 2 centimeters to represent 2 units, which means the vertical, that's your y-axis. So on the y-axis is 2, 4, 6, something like that. On the x-axis is 1, 2, 3, something like, okay, it's just like this that I'm having. That's our Cartesian plane. As you can see, guys, we are having the x and the y, and that is the scale according to what you are given. All right, so we're not going to waste much time. We're just going to quickly mark our points that we are given. So we are given -2, 15. That is when x is -2, y is 15. So you've got, which is somewhere here, -2 here, then 15 straight. So 15 is actually in between what? In between 14 and 16. So it's -2, which is somewhere here. You mark your point. Then you move on to the other one. It was -1 versus 4. If I'm not mistaken, let's see. -1 versus 4. So you're going to have -1 versus 4, which will be somewhere here, guys. -1 on x, then 4 on the y. Take note, this is where our x is -1, so it's -1 versus 4, and we're given 0 minus 3, so that is 0 minus 3, which -3 is in between what? Is in between -2 and -4, so that's our 0 minus 3 here. Then we are given 1, and it was 1 versus -6. Let's cross check. Is that so? 1 versus -6. Okay, 1 versus. We've got -half. Actually, there's -half that we didn't talk about. It was -half 0 here, -half 0. Okay, then 0 minus 3, then it's 1 and -6. So -6, that's here. That's 1 and -6 at this point. All right, then we've got 2. That was 2 and -5. 2 and -5. -5 is in between -4 and -6. Then we've got 3. It was 3 versus 0 here. This is 3 versus 0. Then 4, it was 4 versus 9. That was 4 here versus 9. So this is going to be 4 here versus 9. 9 is in between what? It's in between 8 and 10. So it's going to be somewhere there. All right, let me just have, okay, sorry. Sorry for this. All right, guys, let me just get back. So this is 4 versus 9 somewhere here at this point. Okay, sorry, I think this part, it cleared everything that I was that I have actually written. Okay, anyways, if you have to check these points, guys, they were actually far away from each other. Take note, first point to this. So for you to join, it was going to be difficult. So what do? You find the points which are in between these points, like we've got -1 and -2. you find the point that is in between. That is when x is equal to minus 1,5. Okay, so when x is equal to minus 1,5, these are points that you can add so that it can fit. Remember, here we had 0 at minus 5. So we are now saying when x is equal to in between minus 2 and minus 1, we've got minus 1,5. So if we substitute minus 1,5, y is equal to 2 into minus 1,5 squared minus 5 into minus 1,5 minus 3 like this. Okay, so you're going to obtain the value of y being 9. So this is what you're going to do so that your graph can at least have points which are close to each other so that you can join proper. So you just find points in between. So you're going to have minus 1,5. Already here we've got minus half. So in between 0 and 1, you find when x is half, when x is 1,5, when x is 2,5, when x is 3,5, you do that. Okay, so this, when x is half here, you're going to obtain minus 5. When x is 1,5, you're going to obtain negative 6. When x is 2,5, you are going to obtain minus 3. When x is 3,5, you're going to obtain 4. So these are the points that you can add. It's not part of your question, but you can do that so that at least it can help you to have a nicer graph. Okay, so minus 1.5 is between minus 1 and minus 2. That's minus 1.5, which we said is going to correspond with 9. So minus 1.5 versus 9 is somewhere here in between. So as you can see, these points, they're now a little bit closer. All right, we move on to half. We said when x is a half here, which is 0,5, sorry, before half, we have got 0,5 versus minus 5. So this is minus half in between minus 4 and what? Minus 6. Then when x is 1,5, which is in between here, we said 1,5 versus minus 6. So it's 1,5 versus minus 6, which is here. All right. Then 2,5, we said 2,5 versus minus 3. So minus 3 is here. Then 3,5 versus 4. So this was 3,5 versus 4. 3,5 in between here versus 4 like this. Okay. So as you can see, the points now are a little bit closer to each other. So you just make some adjustments when you are doing this question. So now at least we can join these points, make sure that you just have something which is smoother to the points that you are given, of which you can draw something which is smoother than the one that I'm having here. Okay, something like this, a curve here. Then we can join these points. All right, so that is what our graph now was going to look. As you can see, guys, we can even try to have a nicer graph because the points, they are closer to each other. So this is the graph of y is equal to 2x squared. So you're going to write the equation 2x squared minus 5x minus 3. All right, so that was the equation of the graph. As you can see, guys, it can be something smoother than this. Okay, but anyways, that was our graph here. Everything is there. So after that, the question now is for us to, let us see the question, find the gradient on item C. So this is now item C. Find the gradient of the curve where x is equal to 1. So guys, I told you gradient, you must draw a suitable tangent at x is equal to 1. So at x is equal to 1 on our graph, this is 1 here at this point. That is where we are going to have our tangent. Direct 1 corresponds with minus 6. So you draw a suitable tangent at that point. All right. So this is what you're going to have at minus or direct at minus 1. So this is our minus 1 at this point. Yeah. We draw a tangent. So a tangent, remember, it's just supposed to be something of this nature. Yeah. Just a tangent, at least 3 centimeters long. We have got your tangent. All right. So from the tangent, now we need the gradient now from this tangent. So you can just put this as item. This was C. Okay, so this is part C. So remember gradient, we need 2 points. And I told you the first point is the one that you are given when x is 1. When x is 1, the value of y here is minus 6. So we've got a point of 1 minus 6. And another point is your choice now. Okay, so just pick another point of your choice, which in this case, we can have 0 minus 5. So which means we have said 0 minus 5 here. That's a point. So you can write your point 0 minus 5. You're done. So using these 2 points, what do we need? We need the gradient. So I'm just going to name my points x1, y1, x2, y2. So the gradient now is equal to the change in y over the change in x, which is y2 minus y1, x2 minus x1. So y2, that is minus 5, minus y1, which is minus 6. Everything over x2. So our x2 is 0 minus x1, which is 1. Okay, so from there on your calculator, everything can be simplified, or you can just ahead, which is minus 5 plus 6 over minus 1. So that's 1 over minus 1, which is minus 1. So that was our gradient. And this is the exact gradient that I'm talking about that time I just determined. So yours is supposed to be plus or minus 0.3 from this one. Plus or minus 0.3. Your answer is supposed to be in within. If not, that answer is wrong. Redo your tangent, redo your gradient, and actually you can find the exact answer. All right, so that is it, guys. Okay, the point that I was working in this one, 0 minus 5, and this one was. So you just choose 2 points, guys, just two of your choice, which are on the graph. Okay. Anyways, let us move on to the other part of the question. We are now given here. We have this. Use the graph to solve the equation. I want you to see, guys, the equation that you're asked to solve. 2x squared minus 5x minus 3 is equal to minus 4. What happened here? If you are to cross-check, this is the graph that we are given before. Y is equal to 2x squared minus 5x minus 3. This was the equation which represents the value of y, which is this one. So now in place of this, they have taken this and substituted the equation instead of y. So you're just drawing the line of y is equal to minus 4, because we are saying this was equal to y. Now it is equal to minus 4. So they are simply saying draw the line of y is equal to minus 4. Where this line meets with the graph, that is where your answers are going to be taken from. So what am I trying to say? I'm going to draw my line, y is equal to minus 4. This is y is equal to minus 4 at this point here, somewhere there. All right, so I'm going to draw my graph like this. Okay, so this is my graph line of y is equal to minus 4. Then where this line meets with the graph, I'm going to have dotted lines with my ruler direct to the what? To the x-axis. So this one is a 0, somewhere here, direct with your ruler to the x-axis, direct to the x-axis. So it is going to meet at this point. Also here, direct to the x-axis, all right? Direct with your ruler to the x-axis, direct to the x-axis. So it is going to be 2, 3. Then this one will be 0, 2. Okay, so this is part D of our question. So on part D, these are solutions, guys. We are writing x is equal to the values that we get 0, 2, or another x is equal to 2, 3. So these are the two possible values of x that we have determined from this part. All right, so direct, as you can see, guys, it was a little bit direct, but you have to work on much questions. Find the area bounded. Take note, bounded by the graph, it means it's surrounded. This was our graph like this. The x-axis, this is your x-axis. X is equal to 1, x is equal to, so where you're going to have something like that. Okay, so this is what we need between the curve, the x-axis, the line x is equal to 1 and x is equal to 3. So let's see it. Okay, so far this is what we have. This is our graph here. This is the graph, the x-axis, and x is equal to 1. This is x is equal to 1 here. All right, so let me do this so that we can see this one clearly. All right, so at x is equal to 1, we are going to draw our line here. X is equal to 1. You write the equation of the line. So I'm just going to draw, maybe, let me use the red one. Okay, this one, x is equal to 1. This is our x is equal to 3 here. X is equal to 3. All right, so that's what I'm going to have here. All right, so on these ones, I'm having x being equal to 1, x being equal to 3. All right, now we are saying this is bounded by the graph, the x-axis, and these two lines. So we're talking about this region, this one. This is the region that we're talking about under the graph, between the graph, the x-axis and these lines. Okay, so what do? I told you guys, you count all these boxes that you see here in this region, which is bounded by the graph, enclosed by the graph, and these lines at the x-axis. You count all these boxes, okay? So remember our area, this is, I can even write it here, this is E. Remember I told you area is equivalent to the number of boxes number of boxes over 100 times the area of the unit square. Okay, so the area of the unit square you calculate from the given part that you are given, which is number of boxes, how many. So these ones, guys, I calculated, I got something like 291 over 100 times the area of the unit square, which is this square. This is the square that you see here, the first square of your graph. This one, this is the first square that we are seeing. X is 1 here, y is 2. So you multiply 1 times 2, which is 2 square units. So which means you're going to multiply by 2 square units. Your answer here, you're going to multiply by 2 square units. So from this, guys, on your calculator, you are going to represent, you have something like 5,82 square units, or you can write it in words, square units, like that. Okay, direct, as you can see. So you've got 12 marks from this part. So guys, please, do revise these questions, do revise. These graphs are easiest of all, the quadratic, the inverse, the cubic, whatever that you're going to have. Okay, so you've got 12 marks there. And the last part of the question is statistics. Yeah, this is statistics. You are given Zimbabweans living abroad. Okay, so this is a graph of what? Of Zimbabweans who are living abroad. Okay, so we are given Australia, Botswana, South Africa, UK, and USA. So these are the countries that we are listed there. And the questions now is, the bar graph shows the results on the survey carried out of a wedding party on a group of Zimbabweans living abroad. Use the graph to answer the following. Okay, so these are the guys who were at the wedding party and they're living abroad. And the first question is, find the total number of Zimbabweans living outside the country who attended the wedding. So we are calculating the total. So this is item 1. So we need the total. Okay, so you're simply taking the total here. In Australia, how many do we have? This is 10, 20. So which means each box is 1, 1, 1, 1, 1, each small box. So this is 19 here. So this is item 1. So we're going to add 19 plus, we move on to Botswana. It's 40 plus 1, which is 41. We move on to South Africa. South Africa, it was 70. So we're going to add 70 here. We move on to UK. UK this is 30, 31, 32, 33. So this is 33. We move on to USA. This is 10, 11, 12, 13, 14, 15, 16, 17. All right, so you add everything properly. 19 plus 41 plus 70 plus 30 plus 17. From your calculator, you're going to obtain 180 Zimbabwean people who are outside of the country, all right, who are at that wedding. State the country in which most people in the survey live. So as you can see, guys, the one that has got the highest bar is where most of the Zimbabweans are. And here we can cross-check, which is what? Which is South Africa here, 70. So which means our answer is just what? South Africa. All right, so we're going to have South Africa. All right, we move on to the third part of the question. Let us see what we are given on that question. Third part, calculate the percentage of Zimbabweans who live in Australia and USA combined. Percentage. Okay, so we're talking of Australia and USA combined. Okay, so this is it, guys. Those who are in Australia, how many are they? Australia, we said it's 19 plus those who are in USA. USA is 17. So you add them over the total number of people, which is there, 180 times percentage. You multiply by 100, just like that. So if we add 17 and 19 together, we're going to have 36 over 180, whatever that we get, we multiply to 100%, which is going to give us 20%, if I'm not mistaken. So that would be 20%. All right. So as you can see, very, very direct, but you need to be very, very specific on your calculations. All right. So let's see the other part. Two people are chosen at random. Now probability, one after. Take note, one after the other. So this is actually without replacement. Okay. Find the probability that both live in Botswana. Both, we are talking about two people living in Botswana. Okay, so let us see what is going to happen. This is B, item 1. In Botswana, how many people are there? Okay, we are talking about 41. So we are saying the first one, for us to pick just the first person, it is going to be 41 out of the total of 180, because remember we've got 180 people there, times is both end, you multiply. So the second one, remember this is without replace, because it's one after the other. We have picked one person out of 41, which means we are now left with the 40. And also it is going to affect the total, because you are saying out of 180 people were there, we have removed one person. So we are going to be left with 179. Using your calculator direct there, you're going to obtain 82 over 1,611. Okay, so that will be those ones who are in Botswana. All right, so I think this one was direct. Let's see the other question. Okay, then this one we are given that the first lives in South Africa and the second, take note guys, they are from different. The other one is in South Africa, the other one is in USA. Okay, so let us start here. This is item 2. All right, so the first one is South Africa. Remember South Africa, they are 70. So it's going to be 70. That is the first one out of 180. But the moment we pick the second one, who is in USA, we are saying in USA, they are 17. It is not going to affect the number of people from USA by picking someone from South Africa. No, it doesn't affect. But it is going to affect our total, which means those ones in USA, they are going to remain as they are as 17. But what have we affected is their total, because we have removed one of the one of the people here who was part of the group, but it was this person was from a different country like South Africa. But the total is the one that is affected, because this person is part of the group. That is why we now have 179. So that was the case. From there, combine everything, you're going to obtain 119 over 3222. And also probability, guys, you can write also as a fraction, if possible. You can write as a fraction, depending with what you want. You can also write as a fraction or as a decimal fraction, it's fine. Okay. Then the other part on C, the survey results can be represented on a pie chart. Draw and label clearly the pie chart. So guys, I told you whenever you're dealing with a pie chart, you need to find the angles first. Okay, so we're going back here. Let us deal with our angles. Remember, pie chart, we need the angles. I'm going to do it here. So this was actual item C. All right, so we are going to start with the first angle. Remember, to find the angle theta is equal to the frequency over the total frequency times 360 degrees. So we are saying the first country that we are talking about here is Australia. Okay, so those in Australia, what was the percentage? We are saying for Australia, the total is 19. So it's going to be 19 over 180 multiplied by 360 degrees. So as you can see, guys, just a matter of your calculator here, 19 over 360 times what? 19 over 180. Sorry, this is 180 like this. All right, times 360, which is going to give us 38. So this is 38 degrees. You move on to the other one, which is Botswana. How many are they? They are 41. So we've got Botswana here, which is 41 over this one. So guys, we do the same for Botswana, 41. Let us just substitute 41 here. Let us put 41. So it is going to be 82 degrees. So this is 82 degrees. We move on to the next country, which was South Africa. Remember, South Africa, they were 70. So we're going to put 70 here. Just as it, guys, like that. You can see that is actually nothing. Okay, so it's 70 here, which is going to give us 140 degrees. After that, you move on to this one, which is UK. Okay, those who are in UK, how many are they? We are talking about 33. So it's going to be 33 over that. You do the same here, 33. All right, so it's 33 here, which is going to be 66 degrees. You move on to the other one, the last one, which is USA. So in USA, how many do we have? It was 17. So it's going to be 17 here. So you just put 17 on this information. All right, so this is 17 like this, which is going to give us 34 degrees. All right, so adding all these, we must get 360 to confirm our answer. So you can just confirm 38 plus 82 plus 140 plus 66 plus 24. We are going to get not 360. This suppose, oh, this is 34, not 24 here, 34. Yeah, it's gonna give us 360. All right, so everything gives us 360 degrees. Then from there, our pie chart. Remember, guys, your pie chart, I told you, you just need a circle that you're going to use to mark all these angles that you are given. So here we need two things. Okay, I think like this, and also the ruler is needed. Okay, so this is what you're going to have, guys. You're just going to construct your circle of your choice. What am I doing here? Okay, let us just construct our circle of our choice like this. Okay, so you mark a point where you're going to have your circle taken from, like this. You mark your point here. So you're going to draw your circle from this point. Okay, so from this point, that's where you're going to draw your circle. I hope it's going to be clear. All right, so let's draw our circle. All right, so this is the circle, which is our reference point. So from this circle, you draw a reference line that you're going to use as your reference, actually, to say from this line, I'm going to take my angles either in an anti-clockwise or in a clockwise direction. So in this case, I'm going to move this way in an anti-clockwise. Okay, so the first one is 38. So you measure your 38 degrees. All right, in this manner, because we are using the anti-clockwise manner, guys, so I'm going to measure, make sure that this line, guys, I told you that it must cover this line. Okay, so something like this here. I just hope it's clear. Is it going to be clear? Okay, so let's see. This will be, I just hope it's directly there at the point. So 38, you have to, let me increase this so that we can clearly see our 38. All right, is it going to allow us to increase? Let us increase 38. So guys, since as you can see, it's not going to be that direct because these measurements, they're too small, and now my eyes, they're actually paining me now. Okay, so anyways, 38 is 30 here, 38, maybe two boxes before 40 here. That's your 38. Okay, you mark your point, then you join from the center to that point. Okay, so you can even, okay, let me reduce here. All right, so let's join. But when you are joining, you're not going to be outside of the shape. You just end at the circle. You don't join outside of the circle. Okay, so it's something like this. Okay, you can join. Okay, something like this. So, all right, so this is what you're going to have like this to the circle. All right, so this is what Australia, this one. So you just write Australia right in full, Australia in full. Okay, you move on from Australia. We are going to Botswana, which is 82. So which means we are now at this point. We are going to rotate it like this to this point here. All right, so you have to measure 82. So 82, that's somewhere here, 10, 20, 30, 80, 80 here, 82, somewhere here, two boxes, 2 lines from that. Okay, so that's your 82. You join again, just like what we did on the previous one. So guys, as you can see, it was actually pretty clear here. All right, so let's see. Like this. All right, so something like this, can join here. All right, so this is what you're going to have. So this is your Botswana here. You write also in full. After Botswana, where are we going? To South Africa, which is 140. So South Africa here is going to be 140. We just have to rotate until it can give us something. Okay, we have to rotate again. Okay, something like this. At the center, it must be at the center. So 140 is actually, because you remember the direction, we are going 0, 10 this way. So 140 is somewhere here. Okay, somewhere there. You can join to that point. All right, something of this nature. 140 to this point. Okay, the first one, this one, not the second one, the first one. Okay, so I want to join to the first one, that one. Okay, so that is your 140 somewhere there. So you can just join to this point. So it means you are now South Africa. So this is your South Africa. You write in full. All right, then we move on to the other one. It's 66 for UK. So here we're going to have our UK, which is 66. Somewhere here. All right, so 66, that's here, 0, 10, 60, 65 here. So 66, somewhere there. Yeah, then we can actually join. So I'm going to join to the center, to that point. All right, but inside the circle or to the circle, you are supposed to meet at the circle there. All right, so this is how it is going to look like. Okay, like this. Okay, something of this nature. You can join from the circle to the point, which is the center, like that. So by doing this, we are now having here, which is our UK. Then definitely the last one is going to be a USA. So take note the direction. I was moving this way in an anti-clockwise. You choose one way to move this part, either clockwise or anti-clockwise. But as for me, I was using the anti-clockwise. So that is what we're going to have at the end. That was our pie chart. We need the angles. Then after the angles, we can actually present. Okay, so that is what we had in this case, and that was our last question actually. So that's it, guys, from this question. So all we need is to work on match question papers as we are towards the days of writing now. Let us revise match question papers as much as we can, because actually we do not have time. So that's it, guys, from Mason African Motives. Till we meet again.